In video 4-4, we are going to be looking at similar figures. By the end of the video and work time in class, you should be able to say, I can use proportions with similar figures. Similar figures are the same shape but different in size. Congruent angles are equal angle measures. So equal is the same as congruent. They are the same. They're identical. Similar polygons are when the corresponding angles are congruent and the corresponding sides are proportional. So we'll first look at corresponding angles. Corresponding angles, if I'm looking at triangle A and triangle B, when I'm looking at corresponding angles, those are the matching angles. So this angle right here in A matches this angle here in B. And they are congruent. They're the same. In triangle A, this angle right here is congruent to the corresponding angle right here on triangle B. And this angle here, and I'm going to put a little mark here, is congruent to the angle over here in triangle B. Those are corresponding angles, the matching angles, and they are congruent. Now looking at corresponding sides, the matching sides, those are proportional. So if I say that this side is, let's say, 3, and this is 4, and this is 5, and then over here I could say something like 6, 8, and 10. And those corresponding sides are proportional. So if I look, 3 matches 6. 3 is to 6. 4 is to 8. And 5 is to 10. They are proportional. They are equivalent. So those two triangles, triangle A and triangle B, are similar polygons. The matching angles are congruent. The matching sides are proportional. They're the same shape, but they're different in size. Congruent has a symbol. It's a little wave like this with an equal sign below it. And similar has a symbol. It's just one wave like that. So we can say triangle A is similar to triangle B. Here we have triangle A and B. They're different now. And we need to find the side X and the side Y, the missing lengths. And we can do this because if we're being told, and I'm just telling you that these two triangles here are similar, since they're similar, we can find X and Y by setting up a proportion. Because once again, we know that these two triangles have congruent corresponding angles, and then their corresponding sides are proportional. So if we're missing a length of a side, we can set up a proportion to find those missing lengths. So I see on triangle A, I see I have 4.5 centimeters, and that matches the 9 centimeters on triangle B. So 4.5 is to 9. Now I want to know what X is. So I see 7.5 is to the X. So what I'm going to do here is write 7.5 to X. So you can see what I did here in my proportion. I did the little triangle, 4.5, to the big triangle that it matches, the side it matches, which is 9. Then I was consistent. On the right side, I did 7.5, which is on the little triangle. That matches X on the big triangle. So I went little triangle to big triangle equals little triangle to big triangle. And so then from here, I can see that if I look here, 4.5 times 2 is 9. And so then I'm looking here, 7.5 times 2 gives me my X, which is 15 and that would be centimeters. Now if I look to figure out my y here, in setting up a proportion to find the y now is on the little triangle, and the y matches 12 centimeters. And then I need a ratio that gives me two numbers comparing the two. I can do 4.5, once again, matches 9 on the big. Or I could have done 7.5 matches our answer from the previous proportion, 15. So here's our proportion. We see that we're doing 9. We're going up top this time because the y I put on the top. So I'm going to divide by 2. 9 divided by 2 is 4.5, so 12 divided by 2 gives me the y, which would be 6 centimeters. Can you say I can use proportions with similar figures? Here's your output. In the first two images here, I want you to tell me if these polygons are similar, yes or no, and why. So show your work. In this next one, I'm going to draw an image. We have a triangle, and inside there I'm going to draw a line. So really you can see two triangles here. There's a smaller one inside the bigger one. And I'm going to label this from here to here is X. From here to here is 80. We're going to say that this distance is Y. We're going to say that this distance is 20 from here to here. We're going to say that this is 40 and this is 50. So I would like you to find X and Y.